Hello, everyone, and welcome to this webinar, Telit Security, Secure Device Onboarding and IoT Deployments, Part 2. I'm Amanda Slink, Head of Global Events here at Telit, and I will be your moderator for today's webinar. To review this topic today, I am pleased to be joined by two Telit speakers. First, we have Dr. Mihai Voicu, VP IoT Services R&D and Security Technologies at Telit. Second, we have Martino Turcato. Martino is the Head of Software PM at Telit. Just before I hand it over to Martino to start the presentation, I have a few quick reminders. I would like to encourage our audience to interact by posting questions. We will have time to answer some of those at the end of this presentation. Simply submit a question by posting in the box to the right of the slides. Also, be sure to check out the resources section in the upper right-hand corner of your screen for additional information. Finally, we will send out the presentation slides and a replay link to all attendees at the conclusion of this webinar. And with that, Martino, I will hand it to you.
Thank you, Amanda. Good day, everyone. And thank you for joining us in this second part of the security webinar. We will revisit some of the key concepts from the previous session and take you through some practical examples on how to use the technologies and solutions available in our products. But let me first summarize the main points we presented in the first session and give you the context for Mihai's session, especially for those who couldn't attend last time. In the previous presentation, we have discussed why cybersecurity is essential in our businesses and why it is widely recognized that the Internet of Things makes cybersecurity even more important, but also more difficult to achieve due to the varied technical and business challenges inherent to IoT. Security has consistently scored the highest among concerns over the last years in several market research. So when we talk about awareness, the situation has improved a lot. However, various surveys still indicate a significant gap between the perceived priority and the level of preparedness. So end-to-end security must be evolved, must be adapted. It's not a one-time activity, it's a process. And this is extremely challenging for most of the organizations. Now, looking at some of the challenges that we use to introduce our discussion, first of all, the shift to the digitization highlights the tension between the business's needs and the security challenges of the organization. Decision makers frequently overlook the impact and cost of security aspects. They usually continue to think of a cyber attack as an unlikely event, and they fail to take timely actions to build resilience into their systems. So the low preparedness might also be due to insufficient budget allocated to cybersecurity. Sometimes it's not easy to make the business case for IoT initiatives. Allocating a budget and making the case for a solid security strategy is even more difficult if it's not an evident need or a compliance requirement. Designing and implementing secure solutions requires special knowledge, and companies need to build the expertise and the technical skills, which requires a mix of traditional IT knowledge and operational technologies expertise. If we think, for example, about the needs of industrial IoT, there are unique challenges due to a distributed, decentralized structure and large operational technology environment. And this environment is usually not suitable for traditional cybersecurity controls. We also have to factor in other requirements, such as the non-stop mission criticality of processes. Enterprise need to simplify and strengthen processes across the value chain to reduce vulnerability. Therefore, a mature solution must reduce the burden on the enterprise. Also, you need to build security directly into the value chains and the business processes to guarantee a continuum of security solutions. And security needs to be part of the entire product lifecycle and can't be an afterthought. Responsibility and ownership within the organization and within the many different players usually participating in the solution ecosystem is another critical aspect. Also, organization must be able to identify and manage the risks associated to massive data sets and sensitive information. And finally, using a standard-based solution is the most recommended approach, since many of these technologies come with a well-defined security model integrated, and that framework is constantly reviewed and updated. On the technology aspect, some of the top scoring areas that we mentioned are the software and firmware management. That is about ensuring that software, firmware, and security protocols are up to date and that the latest patches are currently distributed. Then we have device management, since securing devices is also strictly linked to securely provision, monitoring, and remotely managing devices. And also identity management and the need to establish proper authentication of assets and protect credentials to ensure trust and reduce the risk of data breaches is another important aspect. Then we go to the first mile of IoT. So to position our offering and understand how this is mapped onto our products, I introduced the concept of first mile, as opposed to the traditional concept of last mile. In IoT, we see this as a first mile, if you remember, because IoT starts with the data generated at the edge. That's the main reason. So getting a device to talk to the large-scale data management and enterprise applications is a real challenge. It's the hardest thing, especially for companies mainly focused on the IT side of the problem. And they need partners and integrators to help them take advantage of those data. And this is the challenge we have taken on at Telit. So helping companies crossing this first mile, simplifying the management of the solution, and the delivery of data to the enterprise applications efficiently and in a meaningful way. So in the diagram, we can see the main elements of the solution. On the left-hand side, we have the edge hardware that integrates the wireless module or is leveraging a gateway for communication. Then data are exchanged over a cellular connection. And finally, the middleware, which is the platform that provides management functions and the connectors to the enterprise system, is delivering data to the enterprise applications. So this path from the endpoint to the apps integrates a fabric of security-related solutions, which span from manufacturing, so having a secure hardware and components, secure software, personalization. Then we have communications and protocols, so secure communications and data exchange over VPN, over secure cellular connections and other protocols, system operations, and business operations, which involves for provisioning, billing, onboarding, software updates, and then finally all the auditing related issues. And now going to One Edge. One Edge is the Telit award-winning solution. It's an integrated suite of software components and services to bridging and managing the first mile. The framework is summarized by this circle with the 5 pillars of One Edge. And in the next slides, we're going to touch on some of these functions during Michael's presentation. So you will see some of these features in action. On the 5 pillars, we have, first of all, device management, which is one of the key functions to guarantee sustainability and scalability of IoT deployments, the QoS of the solutions, and of course, the security. you will see the relevance and the importance of lightweight M2M in the context of One Edge to implement device management functions. Then we have Edge Intelligence, which is the set of functions and tools to define the behavior of the device and securely send and receive data to the server. Cellular Connectivity Management, which includes the integrated SIM and the connectivity management on the portal. Enterprise Integration, which is comprised of the tools needed to facilitate the integration with the enterprise system. And finally, security, which is related to end-to-end encryption, but another important aspect is the pre-provisioning, which happens at manufacturing time. That simplifies the initial installation and onboarding without exposing the secure assets and avoiding manual configuration. So each module is provisioned with a unique identity injected at the manufacturing time. This identity is immutable and is shared along with the keys and certificates with the Telit platform before the module is shipped to the customer. All modules support the secure boot, and the firmware is signed and relies on a secure root of trust. For the modules that support integrated SIM, there is a Simwise preloaded in production with a set of specific profiles. And finally, we provide TEE-based crypto microservices. So this is basically an abstraction layer for crypto operations, for secure storage, encryption, decryption APIs, and security functions. And all these sensitive operations are performed inside the trust zone execution environment with no access from the user space. But I will hand over to Mihai and will let him elaborate more in detail and touch on some of these features.
Thank you, Martino. Good morning, good afternoon to everybody. Last time when we finished the webinar, we actually discussed a demo that we're going to present it. So I'm going to take you today in a journey from how we actually provision one of our modules all the way to how we actually connect it to the network and highlight the significant features or security features that we put in the module, as well as into the platform, as well as in what we put for our secure manufacturing. So last time we discussed about these pillars that are into our infrastructure. We start with a telecommunication, which is something like an MNO. You need some communication of any kind. We had also a Telit warehouse with credentials. We had a manufacturing facility that we need to interface with. We have the platform that we interface with. And also the last element on this is the module itself. So as you can see in this diagram, everything that we build around the capabilities into an ME910 module. Each of the features are related to how to put credentials into the module, how these credentials will be shared with the platform through our manufacturing facilities, and also how we are going to make the module available into the IoT portal. And from there, we're going to operate a couple of things regarding Simwise. So that being said, last time we left our discussion with this. Okay, we started in showing a sales kit that is used. It's using all the capabilities for the ME910, coming from some LEDs that can be manipulated, all the way to some Simwise. That means a seamless connection, and this is basically a video of that particular sales kit in action. And you can see here there is no SIM card. Everything is incorporated into the module itself. That means we have a Simwise and also we have a profile for the respective carrier, in this particular case, AT&T. And you can see that it's a CAT-M. So what I'm going to show next is each piece of the security that we build up to put into this module and make it connected. So we're going to talk in the next few slides, we're going to talk about what we introduce new AT commands. We're going to talk about what we have done for the Lightweight M2M, especially for the connection from between the module and the portal. And also we're going to talk about how Simwise and how to operate a module which can have either a virtual SIM or a physical UICC. So let's introduce ME910 properly. The set of features that you see here can be available for everybody to check them at our website. The link is right there. I want to highlight a little bit what is important for our discussion today, especially for the security part. There is a OMA compliant Lightweight M2M client inside. There is a capability already by default for Simwise. That means you have a SimOS that has been stamped in at the manufacturing, as well as there is a profile specific for this module, which will have an ICC ID. And also, through the firmware, we have a set of AT commands and also a set of APIs that can be invoked either through an application, directly AT commands through an application, or an application into our AppZone capabilities through APIs. More details, I think you can find them in the website, and I'm not going to introduce the rest of them because my focus today is in the Lightweight M2M, Simwise, and the AT commands. So let's take a look a little bit under the hood of this ME910. And for that, we're going to use Telit AT Controller. It's basically a capability that allows you to execute AT commands. On the left-hand side here, you have the main screen where you can set up the communication through a port. By the way, for this particular example, the sales kit has been connected through a USB connector into my laptop. And we're going to talk about other capabilities later on. So you're going to see the sales kit as a COM5. There is a speed. Once you connect, the tool is going to report back the IMEI, the manufacturer, the model, and the release version that it's available right now. The bottom section is basically a series of AT commands that automatically the tool involves, give you more details about what actually the module has been set with. So let's take a look to the next slide, which is basically a kind of a highlight of the screen. And it's important for two aspects. First, at the top line, you're going to see the IMEI number. And I want you to remember the last four digits, 1481. Because we're going to follow this IMEI from how we manufacture all the way to provision into our portal. And also the unmasked part is basically an ICC ID, and also that can be used to follow up on our journey here. Okay, so that being said, let's take a look correctly to the following. For a second, I'm going to skip this slide and I'm going to come back to it. What we have done into our modules into the ME910, basically, in order to store all the credentials, to store all the profiles, to store the SimOS, anything that is really private and confidential and is needed for the functioning of the module, have been placed in certain areas. And what we call that is the secure data area. The module is equipped currently with three areas. One is a Telit, a particular dedicating area. The second one is a customer dedicated area. And the third one is an operation dedicated area. All three, these secure areas are encrypted by default with the key that is specific to that particular module. And the key resides and has been provisioned, let's put it direct, at the manufacturing into the trust zone. There is no capability to extract that key outside for any decryption of the files. Now, coming back to the previous slide, once we understand that there is this capability of having files in a secure area where you can store certain things, we build on top a set of security commands. You can have the ability to manage that area. What that means, you can access it, you can lock it, you can make it read-only, you can make it whatever you think is needed for your operations. You have also the ability to read the current secure data area. That means if you're a customer, you're going to be able to read it from your own partitions. You can write data, you can write a file, you can write specific binaries, you can write specific strings into the data. You can also write it encrypted. So this is the two capabilities. One is just basically it can be a binary and you can just write it, or you can actually say I want to write encrypt or encrypt a certain data into this particular storage area. You can delete one. Also, you have the capabilities to move data into the module RAM. It can be encrypted or decrypted. That all depends on your operations that you want to perform, so that you can prevent any executions, malicious executions. You have also the ability to check if a particular file that has been loaded is being loaded correctly. You have a set of checks in place. Another capability that we had is the generation of set of public and private keys. And that particular command has been explicitly presented here as an example. You can see that set K. And also, throughout of this journey of security, we have implemented a strong capability for Telit ID, and that particular ID is unique. And this has been discussed with many in a little bit detail more in the previous part into our webinars. Now, unfortunately, I could not get the real security commands. You can see those XXS there. Due to the sensitivity of this information, we can share it only under NDA. And please reach out to me, Martino, or our marketing, or directly into our website, and we will get in touch with you for getting all the details that are necessary. We have a full documentation about these commands, and it will be available under NDA. Now, we discussed about the secure data. Let's move a little bit of what we have built to create these APIs. And for that, I want to bring you what we actually have done inside of the modules. As everybody knows, the structure of a cellular module comprises of a user space, a kernel space, and a modem space. We have created a unique interface between the user space and the kernel space in such a way that certain capabilities will be exposed for encryption and decryption or operations, like the ones that you have seen, will be exposed to the user space. But in the same time, we have the abilities inside of the kernel space, as well as in the modem space, for operations that are dedicated and only dedicated for example, network communications for our Simwise products. All of them are actually backed up and executing into the trusted execution environment that is provided into the ME910, which is a trust zone, the ARM trust zone capabilities. So in reality, all of these are build-ups one by one, layers of security in such a way that certain capability will be exposed at the certain levels for the user and our customers to be used. Now, that being said, now that we have this introduction of the ME910 with capabilities with 80 commands and APIs, I want to take you to actually a direct example of how we do certain things. And what we did here is a sequence of commands that will allow a certain file to be sent into the module through the AT interface. For example, in this case, the Telit AT controller. And this file is encrypted with a share key. And also, I'm going to show you the ability to send that encrypted key and store it into the trust zone. And the file will be encrypted with that particular key. File will be transferred into the modem space, and that can be used later on by applications that are inside of the module, and operations can be used to decrypt that file for different purposes. So there are 10 steps here. I'm just going to go quickly. I'm not going to go to a lot of details. This is very technical. People that are in the crypto space, they will understand some of these elements. But what I want to highlight is where we introduce and why we introduce a certain AT commands in an example, which is a combination of OpenSSL and AT commands. So first of all, we need to create the share key. With that share key, we are basically we encrypt the file in the second step. The next step basically will, after this file is encrypted in a particular machine or something that is really secure, we're going to generate the local, that particular PC or that particular workstation, a private and a public key in steps 3 and 4. Now, with number 5, we can introduce the first AT command, which is a sec-k. That particular command, when it's executed, will actually generate a private key that is stored in the trust zone and will export a public key. And you can see here the output. When you see 3EBE is basically the PEM format of the binary key, in the public key. That being said, the next step will basically say we'll use a certain type of algorithm, like a DH algorithms, to generate a shared or a session key, which is a key used temporarily to transfer information between the workstation and the module. That there will be some conversions here from binary to PEM format. In number 7, we'll encrypt this key with the share key. The initial key that was the one that needs to be, the file has been encrypted, will be encrypted with the share key. And the second, number 8, is writing actually that share key. It's writing that file. Number 8 is writing the encrypted file into the module. Now, in number 9, we are writing the shared key, the initial key that the file was encrypted with, using a special command, sec, in details you understand about that. And after that operation, there is an extra command, number 10, that will allow us to verify that the transfer of the file, encrypted file, has been placed in a certain particular location and has a good integrity. So this is an example of how someone will be able to send an encrypted file. That encrypted file can have anything inside. In the same time, the AT commands that we put, this is not only one way of doing it. There are specific commands that can be used specific to add information or encrypted data into the trust zone, into the SDAs, especially for the customer part, and also for the operational part. What's happening in the TDA at this moment? Only at the manufacturer, certain things can be put in the TDA, and only by Telit needs. Also, the infrastructure of our manufacturing, secure manufacturing provisioning, allows us to put information into the customer dedicated area, the CDA, so that they will be there at the beginning. Those can be simple things, and I will explain to you later on when we're going to get to the Light One M2M. Simple things like URLs that are, even though they are visible, they have to make sure that they are not altered. So this is another case. Now that we finish here, let's go and discuss a little bit about the Light One M2M. Light One M2M is a protocol. You can get the specs from OMA. What I want to introduce here is a little bit of a stack and what is important from security point of view. The Light One M2M stack has objects that are representing security. But the most important part of the Light One M2M is the communication, the low-level communication that is built on the UDP. And you can see it at the bottom there. The transport most used today is UDP. On top of the UDP, you have to build DTLS, and therefore you will be able to actually have a co-op communication. So in particular for this exercise and where we need to put our focus is on the DTLS. DTLS basically will require a pre-share key that is established in between two entities. In this particular case is the Light One M2M client that is currently into our ME910 module, and also the same share key needs to be available into the application server or in the Bootstrap server. Now, when we are talking, sorry, wrong button. When we are talking about Light One M2M, there are two significant aspects. One is the Bootstrap server, and another one is basically the Light One M2M server. The Bootstrap server is the server that the Light One M2M module can connect the very first time. The name says everything. It's like Bootstrap. Everything starts from there. And you can see here that in order for a module to connect to a Light One M2M server or to connect to a Bootstrap server, certain keys needs to be provisioned. And in this particular diagram, you can see that we provision share keys in the factory into our module. In the same time, the same key will be placed into our portal for communication with the Light One M2M. But more important, that pre-share key will be used in between. It will be used to create a DTLS session and will be used to connect in between Light One M2M device, which is in this particular case our ME910 module, and the Bootstrap server. There are two elements that are very important here, and those elements are introduced so that we can understand the security of them. One is the Bootstrap server address needs to be factory provisioned. That means we need to have it into the module, and it cannot change. The moment this is available to be changed, things can go wrong in terms of integrity of the system and everything related. The second part is the PSK. All of these elements have been provisioned into the Light One M2M device, in this particular case ME910, using the 80 commands that I described before. So there is a sequence of commands that we build up. If you think, for example, that the file that we just encrypted has these elements inside, think that those can be used for a communication in between the ME910 and the Bootstrap server. So this is particular how Bootstrap works. Now, if we go next, this is a little bit of a highlight of our One Edge architecture. I'm introducing it here because the next steps will be one by one. We're going to actually see how our ME910 in our journey will actually be connected to our platform. So, as I said, we have a module ME910 through the Light One M2M protocol, through Bootstrap and registrations and all the objects that are coming with, will connect to the Telit Portal. And you're going to be able to actually see how we implemented and how we put it in the portal, the ability to have this seamless connection. Once the keys and the pre-shared and the Bootstrap server are set, the module is born for that communication. And everything, once you have it, it can automatically connect to our portal by default. So the next slide is our capabilities into the portal. Here in particular, I'm going to bring up what's called Telit App Center. This particular interface gives you the ability to manage a device. In this particular case, it's going to be our sales kit. Also, it's giving you the ability to do some firmware management, and also gives you the ability to see the management of inside of the whole entire portal from different aspects. We are going to focus for the moment on two aspects. First aspect is how this module, ME910, into our sales kit will be available into the device management app. And second, we'll actually have the ability to see our module into the portal. So this is the interface for the device management that we have it in our App Center. And the next one basically will show our device. As I said at the beginning, we have to focus on the 1481, which is at the bottom, it's in the middle. This particular, it's a sales kit. You see it here available into the list of the devices for this particular demonstration. In order for the module to connect it directly here, what we have done basically at our secure manufacturing provisioning, we have the ability to put in our portal the pre-share key for the Light One M2M. We have, when I presented earlier, was called warehouse. This is the view basically into our warehouse. You can see the Telit inventory for this particular IMEI. And you can see here the Telit ID, and also you can see some other IDs that are related to this particular IMEI. This is the place I want to emphasize on this. This is the place where every single module that has been manufactured with One Edge is available in our portal. This is by default done, and if you use it or not use it, you're going to have it here into our inventory. So the next time when you try to use the portal, we can automatically get you Bootstrap and also give you the access to the portal for the Light One M2M server. Now, this screen actually shows a picture of our portal internal, where you can set up and you can see the endpoint, all the details that are related to the Light One M2M connection. And I actually highlighted a little bit here the ability. We have different abilities that you can have the Bootstrap with DTLS, Bootstrap without DTLS. You can have server with DTLS and server without DTLS. All these capabilities are built in because our platform is generic. You can actually add credentials for Light One M2M for other devices. But in this particular case, for this particular IMEI, all the credentials have been placed into the platform and automatically will use a Bootstrap with DTLS. You cannot actually change it. It's coming by default because we emphasize on the security of this connectivity. Now, we have added, and this is another topic that we can discuss in deeper details, but for the ones that are interested in how to actually manipulate Light One M2M data, I exemplify here a couple of commands. We have a full range of commands. You can see it into the right-hand side where I make a reference about the full set of commands. I have exemplified here how to enable a client for a module to use the Light One M2M client, how you actually set a certain resource. You have different elements, including the commas in between them, and also you have a capability for the get, which basically retrieves information. There are other commands that can be used, but for this particular Light One M2M, just an example of capabilities that can be used. Now, I think we have a little bit of a break. I think Amanda would like to take the control for a couple of minutes. Amanda, please.
Yep, thanks, Mihai. We want to pause for just a moment here to take a quick poll of our audience. What best describes your relationship to lightweight N2M? If you could take just a second to fill out the poll question, which you should all see on your screens now. All right, back to you, Mihai.
Thank you, Amanda. Okay, so the next topic of this presentation is about Simwise. I'm going to introduce Simwise with a couple of general concepts. We're going to discuss a little bit of how we actually secure two essentials objects for our Simwise. But before that, this is a diagram. This shows all the interconnections between Telit, IDEMIA, which is our provider for Simwise, and for our profiles, how the MNOs are getting into the picture, and how the interface between Telit and the device itself at the bottom. The numbers are very simple. We can go over this in a little bit. What I want to point out here is all these interfaces that you have here, 1 to 9, have been secured not only at the transport level, but also supplementary at the application level. Some of them have strong encryption, and also I want to emphasize about our production infrastructure, where all the communication, all the storage have been secured, and they follow a ritual and rigorous procedures and processes. In this way, we can guarantee that certain secured objects like shared keys, which are absolutely needed, are not exposed in clear at any point in time. The next slide shows actually how we put a certain dedicated infrastructure into our module, into our ME910 in relation to the Simwise. For the people not understanding Simwise, or the people trying to grasp the importance of the Simwise, we try to eliminate as much as possible the physical aspect of a SIM. And for that, you have to need two major elements into your module. One is the Simwise, and second is the profile. The Simwise is basically the executor, the process that actually runs constantly and gives you the ability to connect to the network. The profile basically gives you the ability, it's your capability, has the keys and all the reference connections that are being shared with the MNO. In this particular case, in the ME910, for this particular project, we have used Simwise. We have used Simwise and profiles from IDEMIA. In this particular case, all the keys and all the profiles and all the Simwise have been placed into our secure infrastructure, into our TDS, secure storage area for Telit. They are encrypted, and all the keys are actually inside of the trust zone. You can see here a little bit of a picture of how the restricted area compared to the user area has been discussed. You have portions that can be specifically apportioned into our manufacturing, and also the keys and then RSPs are following the GSMA recommendations. And at the bottom, basically, we are interfacing with the chipset, which has a particular TE in place. Now, for an exemplification of this, I actually want to take you through a little bit of a sequence of commands that have been put into the current sales kit. The sales kit has the ability to have a physical UICC as well as a virtual SIM. And by default, when I put this example out there, I didn't have a virtual SIM. I didn't have a UICC card. So the commands that you see on the left-hand side, first of all, I want to exemplify that we are using the same ICC ID like before. All this example has been built on this ICC ID. If we execute a vSIM set profile, we actually get a response saying this particular profile is number 1. And number 1 basically means the profile that is first into our virtual SIM list. If we execute a vSIM set profile equals 0, if we don't have a new ICC card installed, you're going to get an error saying there is no there, so you cannot change it. But if we insert, as you can see in the middle of column, if we insert a SIM card and we execute the same command one more time, you're going to receive an OK saying, OK, I understand your command. You want to switch from a virtual SIM to a normal SIM. And once you see this in the example, basically all the communication will be moved to the physical SIM. Re-execute one more time the vSIM set profile to make sure that we are dealing with profile 0, which is the physical profile. And I'm executing one more time a command to get the ICC ID. And you can see that there is a different ICC ID. So definitely there was a change in between the two of them at this point. Now, the proper example is to go forward and say, okay, if we remove the SIM card, what's going to happen? So I remove the SIM card and I place one more time an ICC ID on that particular command. And I get a SIM failure because there is no ICC ID, there is no UICC available. If I execute another set profile 0, I get exactly the same error one more time because we don't have it. If I set profile to 1, basically the command is executed. And with that, you can see if I execute an ICC ID command one more time, I get back exactly the first one from the top. These commands are available for any application that is residing in our module, or it can be in the MCU and external MCU. And it can be actually very valuable if you want to do certain aspects when you have different profiles that you want to use. And by the way, on our Simwise capabilities, we can store up to 10 profiles. And you can have as many as 10, and you can use one at a time for each of them. I think at this moment I'm done with this. I'm going to take it back to Amanda for the final section.
Thanks, Mihai. Before we get to the questions, I'm going to drop one last poll here on your screen. If you'd like to have one of our experts contact you, please respond here on the poll and someone will reach out to you. We now have time for a few questions. There is still time to ask a question, so please submit using the box to the right of the slides and we will do our best to cover it. We've had a couple submitted already. First question, how does security relate to or affect IIoT devices when they are connected to IT systems?
I'm going to take that, Amanda. So if we are in an industrial space like a factory or a plant, introducing IoT devices that are using cellular communication in this particular case, and also different other means, it can be a LAN connection or the Wi-Fi connection, will present a lot of challenges for the manufacturing. Most of the times, those must go through a rigorous attestation for that particular factory or for that particular plant. Most of the times, they are not easy to be controlled by any IT systems. Due to the nature of these IoT devices, you're going to have a very hard time mapping them and controlling them. Mapping from a point of, they can be bought in for different purposes. They can connect to clouds in different means. They can actually create VPNs into your infrastructure. There has to be, you have to pay a huge attention to these particular devices. Try to understand them as early as possible. Try to be in control of who purchased them, from where do they purchase them. Make sure that that particular vendor is actually in your approved list, and try to put as many controls as possible if it's capable, so that you can map it into your monitoring or your policies, into your procedures. Next to you, Amanda.
Yep, thanks, Mihai. Next question. SIMless connectivity and Simwise were not 100% clear from your presentation. Could you please map these approaches to market terms such as consumer eSIM, M2M eSIM, EUICC, iSIM, etc.?
Yes, I'm going to take this question, and it's actually a good question, so let me provide some more details here. First of all, the example you have seen here specifically in the demo from Mihai for Simwise was based on a iSIM. So just to align with the terminology, when we talk about EUICC or eSIM, which is a synonym, we're talking about discrete secure element designed to remotely manage multiple subscriptions and compliant with GSMA specifications for remote provisioning. And the EUICC form factor is a soldered SIM chip, which can be VQFN8, MFF2, or WLTSP. There are so many different form factors. But from a functional perspective, it can also be traditional plastic SIM card. The IUICC or iSIM is basically, as Mihai was describing in his slide, same operating system, which is integrated in a secure application, running on a secure area of the chip. In the case of Simwise, running on a TEE of the processor. So if we compare the various solutions, there are different aspects to evaluate and different benefits to take into account, and this depends on the use case or the carrier requirement. So, for example, if we look at the iSIM from a footprint perspective, it's much better. Also from a durability and environmental point of view. So cost as well. We have the eSIM and iSIM are also much better if you look at the logistics of the lifecycle management of the SIM, and so there are different aspects to be taken into account when choosing the solution for an IoT device. And at Telit, we have various solutions in our portfolio and in our roadmap for the products that are coming up in our module portfolio. This is ranging from the Simwise on the 2G that does not support the remote provisioning, Simwise on the 4G will support the remote SIM provisioning. And so it's a full GSMA implementation. And we also have modules with the integrated SIM chip. So we are basically covering all the different scenarios depending on the use case and the requirements.
Thanks, Martino. Next question here. Do you use a standard TEE in Trust Zone, or did you develop your own?
I can take that, Amanda. Basically, the Trust Zone TEE has been provided to us by Qualcomm. We have interfaces with them. We know how the Trust Zone works. Also, Qualcomm has helped us in terms of what can be done inside of the Trust Zone, giving us the ability to understand how the execution is happening, and if we can use certain capabilities, for example, secure file systems or not. Also, the ability to understand how memory copyings are happening for protection of the keys. And in this way, we are able to use standard ways of doing it. Next thing.
Thanks, Mihai. We're coming up on the hour here, so we've got just one more question. I think we've got time to answer. Does Telit One Edge only interface with the Telit modules or other system components like the host computer or device?
Okay, I can take this. So One Edge has been designed in order to be an integrated solution. So the idea is to offer all the module-related features available out of the box. So for example, you can take advantage of the main device management functions just by enabling the service, using the defaults, and without even the need to configure a single parameter. You just activate the agent, and then you're good to go. But the framework, of course, has been designed to be extensible, and so it's easy to factor in the elements that are specific to the customer application, and the data that needs to be that are specific to the device and the sensors hosted on the device that needs to be sent to the server. So typically, these parameters and these characteristics can be mapped onto an extended object model of the lightweight end-to-end. So just by describing the resources to be transmitted or received by the server, or the commands to be executed remotely, you just create this new object. You import an XML description file, and this is done by using a tool that is offered by Open Mobile Alliance. And so you import this description file in the module, in the portal, and then you just need to feed the objects or connect the events and the actions that are associated to the newly created resources. And it's a low-code process that usually takes only a few hours to create a POC, which is ready to be tested. But then it can be easily translated as is to a production environment once the testing in a real environment is completed. Also, some other cases for some class of devices, typically high-end devices, we can also offer a software component, which is an external agent that can run directly on the host CPU.
Great. Thanks, Martino. I believe that's all the time we have for today. Please be sure to check your inboxes in the coming days for the slides and replay link. Thank you much to our speakers, Mihai, Martino, and thank you to all who joined us today.